So just to save space, I'm gonna use the form of writing a continued fraction that Mathematica uses, just so I can save space. So Mathematica would tell us, when I ask for the continued fraction, it's gonna tell us 0, 3, 6, 6, 6, like that. So what do you think that means?
0 plus 1 over 3 plus 1 over 6. They just exclude over and over.
Yeah.
Because it's always there.
Yeah. And so we want to figure out what this is as, if I gave you this, I want to be able to turn it back into 1 over the square root of 10. Do you know how to do that?
No.
No.
Yeah.
Okay.
Because you can do it if it's a finite continued fraction.
Oh, yeah. How
You
do you
can-
do that?
You can start from the bottom and then just slowly just get rid of the continued terms, and then you can work your way up to the top.
Right, so that's a great observation, is if we had a finite fraction, like 1 plus 1 over 2 plus 1 over 3, we could just start rationalizing and work our way from the bottom back up to the top. So we need to figure out some way to turn this expression into something finite. And where do you think the easy part?
It's probably right there.
Yeah, so what we want to do is ask what this continued fraction, 6 plus 1 over 6 plus 1 over 6 equals. If we can figure out that, which occurs 3 levels down, depending on how you want to count it, we can simplify this.
Yeah.
Okay. So this is actually kind of a fun thing to do. We don't know what this is, but we do know it repeats itself down here. I get the same thing, right? 6 plus 1 over 6 plus 1 over 6. I get the same, whatever it is, it's the same down below the first level.
Yeah.
So if I say that this whole thing is x, I get a very simple equation. 6 plus 1 over x equals x.
Right?
How do I solve this?
Well, you multiply by x, and you get x squared is 6x plus 1. So you have a fairly simple quadratic now.
All right, how do I solve that?
You have x squared minus 6x minus 1 equals 0.
All right. Sorry for all the erasing. X squared minus 6x minus 1 equals 0. I solve that using what?
Using the quadratic formula.
Okay, so I get 6 plus or minus the square root of b squared,
36.
plus 4, so 40, all over 2, which is 3 plus or minus the square root of 10. Because a 4 comes out of this, turning into a 2.
Yeah.
Now which one is it? Is it 3 plus the square root of 10? So 6 plus 1 over 6 plus 1 over 6 plus 1 over 6. Is that 3 plus the square root of 10, or is that 3 minus the square root of 10?
Well, it's going to have a positive value, so I think it'll be 3 plus root 10.
Yeah.
Okay, it also starts with a 6. So only one of these is really close to that.
Yeah.
Okay, so we get this part here turns out to be 3 plus the square root of 10. So now I do have a finite continued fraction.
Good.
0 plus 1 over 3 plus 1 over 3 plus the square root of 10.
Alright.
What do I do to start simplifying this?
Well,
You just have to start from the bottom.
so you can multiply everything by... Actually, which would be easier to multiply? We multiply by root 10 minus 3. Or we can multiply by 3 minus root 10.
Oh, whatever you like.
It'll end up being the same, but
I just want to simplify this right now. So
I'll multiply by 3 minus root 10.
3 minus root 10. Okay, what can you tell me about multiplying by 3 minus root 10 over 3 minus root 10?
Well, we're going to have a negative on the bottom.
Okay. So what does this end up equaling?
So it's 3 minus root 10 and then times minus 1. Or, so root 10 minus 3.
Okay, so hold on, let's see. What does the bottom end up equaling?
Minus 1.
Okay, so I get 9 minus 10. So on the bottom I would get minus 1, and on the top I get 3 minus root 10. So how does that, can you tell me how that simplifies?
Minus 3 plus root 10 over 1.
That's right. So this becomes root 10 minus 3. Okay. So with all this calculating we've done, this just becomes root 10 minus 3. How does the bottom simplify now?
you just multiply by this.
What is it? What is on the bottom?
3 plus root 10 minus 3.
Okay.
So it just simplifies root 10.
Right, so the bottom is actually just root 10. So now I have 0 plus 1 over root 10,
Which is what we want.
Yeah.
which is just 1 over root 10.
That's what we want here.
Yeah, so in fact we're now able to go forwards and backwards. So once I give you a continued fraction that repeats anyway,
Yeah.
you just go to the part where it repeats, figure out what that is. That turns your original infinite continued fraction into a finite one, and then you just work your way up.
Cool.
All right. Now we're going to go up to the computer
Alright.
and look at the continued fraction for square root of 5 minus 1 over 4. And we'll see how close it is to this one.
Yeah.
Okay, and then we're going to get a fun surprise.
Alright.
All right?